Hey everybody, this is Larry. This is day 12 of the June Leetcode Daily Challenge. Hit the like button, hit the subscribe button. Let me know what you think. How did you do in this problem? Did you do okay? Was it interesting and all that stuff? Okay, cool. Insert, delete, get random all of one. Design a data structure that supports all following operations and amortize averaged all one time. Insert value, which inserts a value. Remove value, which removes a value. Get random, which returns a random element from a current set of elements. Each element must have the same probability of being returned. Okay. Yeah. The first thing I think of to get all one is to put insert and removal in, like with a set, right? It's very it's hard to get it without that. Maybe other than some counting sort or something like that, but that also allows you to handle dupes and stuff like that. And of course, the caveat or the thing to always mention is that with a hash table or map, the outro one is a little bit not as tight, but that's okay. I think that's usually on interviews. That's why what they're looking for. And then to get random, you need a way to get a random element from a set, which is a little bit tricky. I'm thinking of just like figuring a way to map all the insert with value into the set, and I think the way that I want to think about it is, yeah, and because I think the way that I would implement it without the removal, for example, is when we insert, we just put it in an array, and when we have an array, we just get a random element from the array. Now, how do we do the removal? Well, when we remove an element, the problem with well, the good thing is that the order doesn't matter in the array. So in a normal array, let's just say in a normal array, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 or something like that. And let's say you want to remove 6, right? If you remove 6, usually what you want the answer is to be this 1, 2, 3, 4, 5, 7, 8, 9, 10. But what we actually in this case we actually don't in this case we actually don't care because it's a set, so you actually can and because you never see it anyway, it's in some random value, you can actually just change it, or not changed, but delete 6, keep a placeholder, and then move the last element, I guess, to that element. So this moves the 10 there, and then we move the last element. And the reason why we do this is, well, because that's what the problem asked for. You needed to keep an O of 1. Otherwise, removing an element from the list is going to always be O of n on average, because if you remove the first element, it shifts everything from the right to the left, right? So okay, so now that I think that I have a technique or an algorithm, and we could show that insert in this case would just be all of 1. I mean, we'll go over it again once we write the code, because inserting to a set and appending to a list is all of 1. Removal, as we talked about, should be all of 1, and get random should just be also all of 1. Yeah, okay. So again, the first thing I would also say is that in different languages, you might do the randomness part differently. Experiment with it, play with it, do whatever makes you feel comfortable. But I just want to get started. Okay, let's do it. Let's start coding it. So self dot and let's just say this is equal to just a random list. Self dot table is equal to a hash table. So insert, let's say if value is in self dot table, that means that means that, well, I guess technically this is a key, but it's a little confusing. But if the value is already in table, that means we don't have to do anything. So we just return. Otherwise, we want to append value. And then the index of this would be the length of self.list, maybe -1 probably. Yeah, because if that's 0 elements, then it should be 0, and then now it's 1. So yeah, so something like that. So that's easy. The removal, let's do the GetRandom first, and then the GetRandom, it should also be straightforward. We just look at the list and get a random element. Give me a second, actually. I'm just googling the Python random library. I don't actually remember that much. So I could use random. So I could use random range, random int. I think there's also a choice in a sequence. Let's use choice today. I think I did it on stream the other day with random int, but you can do it in either case. But yeah, we'll just choose random.choice. So return random.choice of self.list. And of course, on an interview, just ask what they prefer, because this is just, of course, this is just like self.list of like random.random int of, or something like that, from 0 to length of self.list -1 maybe. Something like that, right? So there are a couple of ways to do it. They're all equivalent, give or take, and off by 1. But just, communicate with your interviewer to make sure that it's okay to do what you're doing. And also, even if you do it the other way, even if you do it this way, be like, oh, I know that there's a standard library in Python that does this, so I would have done it that way. But of course, in an interview, things are a little artificial, right? Obviously. Anyway, removal. Okay, we did what we said. So okay, let's just say if val is not in. So if this value is not in the table, then we don't have to care about it. I think we don't have to return anything, right? Yeah. Okay. Oh, do we have to return? Oh, okay. I didn't notice it didn't say, but you have to return true if it's inserted correctly. So okay, so we have to make some. Yep. So this is false. Return true. So now we move 1 from the set. Okay. And then return true. So if it's removed, then it's true. So okay, so this is false then, and then at the end return true. And then how do we remove? Well, the index is equal to self.table of val, and then now what do we say? We want to get the last element and then move it here, right? So self.list of index is equal to self.list of last element. So that's just -1 in Python, but you could do like n minus -1 or something like that. And then self.list.pop, I think pop left should remove the element that's to the right. Unless my syntax is off, but that's general idea, should be okay. And then now we remove it from the table, and we remove the last, and then we want to update the element that we just updated to the new index. Okay. I think that should make sense, unless I have like an off by 1 or typo. Is this true? Didn't you tell you if it's correct or not? Okay, fine. That's just for funsies. We print a few more. Looks okay. Okay, let's just submit it then. Ooh, one-time error. Remove, insert, GetRandom, remove, insert. Huh. Okay. I mean, like I said, off by once always a little tricky. But which... So it's having issues with remove, but which remove is it having issues with? Oh, I see. Because I did miss an edge case. But the thing is basically if you're removing the last element on a list, then this is not true. So okay, so let's do this here first, and I think that should be okay. Yeah. I was just, to be frank, I was just a little bit careless with the ordering of things. And the reason why we want this line here instead of where we had before, I just forgot to do it, and then I forgot to think about it because I was a little bit confident. So not in a good way, arrogant maybe, but yeah. But basically, I thought about this while I was typing it, but then I just forgot to follow up. But which is that when index is the last element, then this removes the element, and this removes the element from the table. So when you go to here, it already doesn't exist. So that's why it fails. But once we change the order back up, this is basically a no op because it sets what it used to be to itself, and then it pops it. And this is also a no op, even though, I mean, not a no op, it's a spin op. But yeah. Okay, so now let's submit again. Oops. Cool. Yeah. So this is O of 1 because initialization is O of 1. Insert is O of 1 because append is O of 1. Putting some in hash table is O of 1. Removal is also O of 1. Because pop, removing the last element is O of 1. Deleting an element from the table is O of 1. And these are just all, hash table lookups. And GetRandom is O of 1 because it just takes a random number from the list. Actually, I don't know if this is this true. I hope that's true, because if it actually, I don't know the performance profile of random.choice, so maybe I lied here. Let's see. Maybe I lied, to be honest. So maybe I actually would do the other thing where you take a random int from 0 to n, because I'm not sure about implementation. And if I had infinite time, I would look at the source code to kind of make sure, because there are a couple of ways you can implement from this. And especially if you take it from a sequence, you can assume that if it's a sequence, then it may go for one by one versus taking a random element from an index. So actually, I might have lied to you here. So make sure you know your library and the performance, especially for an interview you're about to show off, unlike what I did. It's probably still fast enough, but because a lot of these things, at least in Python, is implemented in C. But that said, make sure you know your implementation. Otherwise, some ego eye interviewer would be like, are you sure? Just like I did now. I'll be like, you are right. So yeah, so this may be O of n now that I think about it again, but there is one way of writing it, which is why we did it this way, right? Random.randint of 0 length with sub.list. So this should be O of 1 for sure. We're here, not so sure now that I think about it again. That's my bad. Cool. Yeah, this is a very data structure problem, so you probably won't get this on a competitive programming, not like this. And in competitive programming, it doesn't really matter that much between O of 1 and O of log n. But in an interview, that's literally the question, and it probably is a reasonable question to ask, though I don't know, because I think the key observation for this one for an interview, or just problem in general, is the thing about removing an element in O of 1 time and noticing that it does not matter, that the order shifting doesn't matter. So you could do something like this, which is a little bit of a weird trivia / trick. It doesn't really come up that much in real life, I don't think, or at least I haven't really been able to come up something off my top of my head. So do it as you will, but still is an interesting trivia, interesting problem solving. And yeah, that's all I have with this problem. Let me know what you think. Hit the like button, hit the subscribe button, and I'll see y'all tomorrow. Bye bye.